Okay, so today we will be starting from the basic of trigonometry and its application in physics. So this sequence that we are covering is from the basic maths first, grade 11, very basic. So we have covered calculus, applications of calculus, differentiation, integration and all that. Of course, problems we have not gone into more details, that we will be taking up in the next few classes. But let us first finish off with basic maths and its application, right? So we have started calculus, we have completed. Today we will see trigonometry, and quickly we will rush up through trigonometry because first these basic things are there, which of course we will be seeing gradually in the problems of physics. But these are basic mathematical tools which the students which are coming from grade 10 to 11 they should be familiar with, right? So let us discuss today trigonometry, trigonometry, basic trigonometry, basic trigonometry, and its applications we will see, and applications and applications. So first thing we will discuss is about T ratios. T ratios means trigonometric ratios. Trigonometric ratios are defined, you know, like the ratios of a side. Suppose, for example, this is angle theta and this is 90 degree. This is a right triangle ABC, and opposite of this angle theta is perpendicular. This is the base and this is hypotenuse. So, first of all, these fundamental trigonometric ratios sine theta perpendicular by hypotenuse, cos theta base by hypotenuse, tan theta perpendicular by base, and the reciprocal of that. For example, cosecant theta, cosecant theta is 1 by sine theta. Is reciprocal of that, that becomes hypotenuse by perpendicular. Then secant theta is 1 by cos theta becomes equal to hypotenuse by base, and cot theta is 1 by tan theta, that is reciprocal of that, base by perpendicular. So these are the six trigonometric ratios, T ratios, which we should know. And what is the application? Lot and lot of applications are there in physics. Starting from the beginning, we will focus on applications. Okay, so we will see that. So first of all, this is a right triangle. So p square plus b square is equal to h square. This is Pythagoras theorem that we already know. Right? And tan theta is also sine by cos. This is also sine by cos. We can write. Okay. Right. So cot theta, we can also write this as cos by sine, cos theta by sine theta. It is reciprocal of tan. Right. Okay. So here these trigonometric ratios are there, and what are the things important in this? What is the value and all that? For standard angles, we should know the values. Standard angles, we should know the values. What are the standard angles? Let us first understand standard angles. And I will give a basic, approach to calculate the angle for any angles, not only just 30 degree, for 330, for 1030, any angles you can calculate if it is coming under standard category. Okay, ASTC rule is there, but ASTC rule sometimes is confusing, right? Okay, so first we should know standard angles values, standard angles, standard angles value we should know. And also we should know that the angle is being defined not as degree. Degree definition is always confusing because degree is not a SI unit. Degree definition is not SI unit. Okay, standard angle first let us note that. So we can take standard angles starting from 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. That means first quadrant, and we can define this trigonometric ratio sin theta, cos theta, tan theta. Sin theta, cos, and tan. Right? So for 0 degree, 30 degree, these standard angles, we should know the value. Sin 0, 0, sin 30, half, sin 45, 1 by root 2, sin 60, root 3 by 2, sin 91. Cos 0, 1, cos 30, root 3 by 2, cos 45, 1 by root 2, cos 60, half, cos 90, 0. Tan is the ratio of sin by cos, so 0 by 1, 0. This divided by this 1 by root 3, 45 degree, this by this 1, this by this root 3 here, and 1 by 0 become infinity or undefined. Undefined. Okay, right. So these are standard angles. You may ask how this is coming, how the values are coming. So for getting the values of this, we need to draw a circle that is called unit circle. So let's understand the concept of unit circle. So suppose if I draw a unit circle, let us draw a circle of radius 1 unit. Okay, 1 unit means 1 meter, 1 centimeter, whatever it is. So this side is 1. Okay, this is 1. Now suppose I want to calculate. I want to calculate what is 45 degree of sine. So what I will do is I will make a like this way, I will make like this. Okay, 45 degree I will make, and then from here I need to drop a perpendicular. Then I will, once you can draw this, you will be able to measure how much is this length and how much is this length. This length when you try to measure it. Okay, and this is 1. So if you measure it by protector geometry, you can measure this length. That length, this comes as 1 by root 2. This length also comes as 1 by root 2. Right? So if you do the measurement of them, this 1 is the total radius of this. Okay, 1 is the radius of this circle. Okay, so 1 by root 2, 1 by root 2 will come by measurement. From measurement, everything can come. Suppose you want 60 degree. Draw a line of 60 degree here and measure the perpendicular and the base. It is like measuring the x and y coordinates, right? You will be cutting on the circle at some point x comma y. So this value is nothing but x here, and this value is y. Okay. So you can definitely measure x and y because you can cut at any angle whatever you like. You cut. You want 70 degree cut, make a line 70 degree. If you want 35 degree, make a line. By using protector and compass and geometry box, we can do that calculation. We can measure these things. So there is nothing new in that. Anybody can do it. But why are we taking this standard angle? Because this value can be easily remembered. We can remember these values, right? So those things we can do. Beside this, one important thing is that there is a triangle whose sides are 3, 4, 5, 3, 4, 5. It is a Pythagoras triplet, and opposite of 4, this is approximately 53 degree, opposite of 3 approximately 37 degree. So that means we can calculate sine 37, cos 37, because from this triangle we can calculate sine 37 opposite by hypotenuse 3 by 5, cos 37 4 by 5. Even if they ask for 53 degree, also we can calculate. Suppose they ask what is sine of 53 degree. So 53 opposite is 4, so 4 by 5. Cos 53 degree if they ask, cos 53 degree. So 3 by 5. So like that, even 10 they can ask. So everything we can calculate in this triangle. We must remember this triangle. So 3, 4, 5 is a Pythagoras triplet. Opposite of 3 is 37, opposite of 4 is 53 degree. This is anyway 90 degree. Okay. So those who are initially coming in grade 11, they definitely they must Remember, because it has got lot of applications in physics, right? And note that this is approximate value. It's not that 53 degree it is. It is approximately 53 degree. Okay, right. So this is standard angles, right? We can remember that. Now, coming to the concept of angles. What is angle? What is angle? Angle is defined between two lines. Suppose this line and this line. If I take two lines, if I take, how to define angle whether this and this? Suppose this angle is theta and this angle is 180 degree minus theta. Then this is also theta, right? And then this is also 180 minus theta. So two angles are coming, right? Which is the angle between the line? The angle between the line is the minimum of these two. Both angles can be defined, but we define the minimum of these two angles. Okay. So angle between two lines, angle between two lines is minimum of minimum of theta and 180 degree minus. The minimum of this we consider as angle. But the thing is that how do we measure that angle? How do we measure that angle? So angle measurements are done in different units. One is the degrees, right? Degree is one of the values we measure that, like 10 degree, 20 degree, 30 degree, 90 degree, all that. Okay, so this degree concept, how this concept of degrees are coming, right? That we try to understand that. That is called measurement in degrees. That is called hexadecimal system. Okay, hexadecimal decimal system. What is this system? Suppose, for example, if I have 90 degree, for example, these two perpendicular lines you take, and this is 90 degree. Okay, that 90 degree, how do we know that it is 90 degree? So they will divide this whatever this angle is, that they can divide it in so many parts. Okay, so first of all, they say that 1 degree, 1 degree is equal to 60 minutes. This dash means minute it is. Okay. And 1 minute is 60 seconds. First of all, what is this? What is this? So this angle is there. This angle, let us divide it into equal 90 parts. Equal 90 parts you divide. How to divide equal 90 parts? That means you have to make so many lines like this. Okay. So this, whatever this angle is, it is divided into 90 equal parts. 90 equal 90 equal parts. 90 equal parts. Now each part, if I take that, each part is called a degree. For example, this. Each is like 1 degree, 1 degree, 1 degree. Okay. So if I divide this, two perpendicular lines, which is like horizontal and vertical, into 90 equal parts. So each part is 1 degree. That is why we say that total 90 degree. Because we have divided this into 90 equal divisions. You may divide it into 100 divisions. So what does it matter? Then you will say that it is 100 degree you can define. Okay. So we are defining as somebody has defined it like this. Some people, old people, have thought it like this. Okay. So some old people have thought it like this. They thought that, okay, let us break it into 9 equal parts. Each part we will call as 1 degree. So that is what is 1 degree equal. That's why this whole is called as 90 degree. Okay. So now this 1 degree which we got it, this 1 degree which we got it, this 1 degree, let us divide into 60 equal divisions. Okay. Let us divide also. These are all these ideas of people from previous generations. They have done this. Let us divide this into 60 equal parts. 60 equal parts. And each part now we will call as 1 minute. Now here is a confusion. Is this minute is the same time or what? No, it has nothing to do with time. People are not like that. They just whatever in their mind it came, they did it. Okay. So in their mind they got it some okay, let me tell minute. So because they thought that minute, second, like the clock, it is like that. Okay. So they are saying that each equal divisions here can be called as 1 minute. This equal division. This minute is not the minute of time. Note that this is called arc minute. Okay, so here one dash means it is called arc 1 arc minute. It is called 1 arc minute. Okay. So each of these parts are equal 60 parts. So each part is called 1 minute. 1 minute. 1 minute. Like that. Okay. Now let us go back to now 1 minute. That small segment, let us take that. 1 minute also let us take that. Okay. Let us try to divide them also into equal parts. Okay. Let us try to take this 1 minute and this 1 minute, this is whole 1 minute. Okay. This is whole 1 minute. Now let us try to divide them also into equal, small equal segments, equal parts. That means we will be drawing so many lines in between to divide them. How many parts? Again equal this 1 minute. Let us divide into 60 equal parts further. 60 equal parts. Hmm? Then this one part, this one part that will be called as 1 second, one double dash. Okay, one double. So what is one double dash? One double dash. So 1 minute is 60 seconds. Means this one double dash means is called 1 arc second. 1 arc second. So degree, minute, second, these are just the units or divisions that some people have defined it and we are just following it because it is become a tradition. Okay. So today I want to define something, I can define something of my own, but people will not accept because already people have accepted this tradition. Okay. They cannot change that, right? So that's how they are defining. So this angle between two means lines, which is horizontal vertical. Why are we calling them a 90-degree? Because this have been divided into 90 equal divisions and each division equal to 1 degree. Then each of that small division has been further divided into 60 equal parts and each division is 1 minute. Again that is small 1 minute, again we are dividing into 60 equal divisions and each part is called 1 second. This is not time, these are the units of angle. Hexadecimal system of units. Okay. That's what people have done it. They have done it and we are just following it. Okay. So everywhere, we generally study degree only. Minute and second we learn differently. But now we have to also know about minutes and second. What about the standard definitions of angle, which is called circular system? Circular system. What is circular system? Circular system means suppose that is some angle theta between them. Let us call it, and you draw a circle. You draw a circle by taking this as center. Draw a circle. Okay. Then the length of the arc which will come here as L, and let us say that this radius which has come here as R. Okay, you can draw a circle of any radius, it is your choice, but there will be arc length coming here and this is radius. So this angle theta is defined as the ratio of arc length by radius. This definition is called angle in radian, and this is accepted as the standard unit. SI unit is radian. SI unit of angle is radian. Everywhere people accept this. Okay? That's how we define this. So this is not in degrees. Note that this is not in degree. But how do I get relationship between degree and radian? For that, let us take one complete circle. One complete circle. is 360 degrees. We know that, right? 360 degrees, one complete circle. So full circle, if I take full circle, then that angle becomes 360 degree. And this 360 degree, that 360 is degree. But if I try to write in radian for full, this is full. If I take, then full length will be what? Let's take this as theta in radian. Theta in radian, if I take full length, become 2 pi r divided by radius. So that will give us 2 pi radian. So 2 pi radian theta, total angle theta 2 pi radian is 360 degree. So 360 degree is equivalent to 2 pi radian. So then we can say that 180 degree is equal to pi radian. Okay. So that's the relationship between degree and radian. If I want to convert radian to degree, degree to radian, we will do like this. Okay. So let us say, for example, I want to convert from degree to radian. Degree to radian I want. So we should know 1 degree becomes pi by 180 radian. So we need to multiply the angles in degrees with this factor pi by 180. Okay. For example, suppose what is 30 degree in radian? So 30 into pi by 180, that becomes pi by 6 radian. So if you want to convert degree to radian, multiply by this factor pi by 180. That will be angle in radian. Okay. Similarly, if I want to convert radian to degrees, then I will take pi radian as 180 degree. So 1 radian as 180 by pi. This whole thing becomes degrees. So this we will use for converting radian to degree. For example, suppose if I have to convert, if I want to convert as pi by 3 radian, how many degrees? So I will multiply pi by 3 this with this 1 by 80 by pi factor I multiply, and I will got the answer in degree. So that will become, from here cancel, it will become 60 degrees. Okay. So that's so simple. To convert from degree to radian, multiply this factor pi by 180. To convert from radian to degree, multiply 180 by pi. You will get in degrees. So this interconversion we should know first of all. Degree to radian, radian to degree, very important. Okay. Then now this interconversion we can do. Okay. Then next. Now, what is the application of this? You may ask, what is the application for distances which are very, very large? For example, distance between planets can be measured. And before we do that, let me give you very important thing. This form means values in NCRT first, second chapter, means basic, when they have discussed, they have given this value. This value we must mug up that. Okay, mug up that. Okay, I will tell, I'll do the calculation with calculator and I'll give the value. So 1 degree is how many radian? Let us keep everything in radian. Why everything in radian? Because radian is SI unit. Let us bring everything in radian. Degree into radian, minute into radian, second into radian, and mug up this. Okay, mug up this. So 1 degree is equal to pi by 180 radian. Let us just convert into values and tell me how much it is. This comes as 0.017, up to 3 digits you can take, otherwise 4 also you can take. This is radian. So 1 degree is so small radian. Note that 1 degree is 0.0174 radian. Remember this, don't forget. Okay. Next, 1 minute is equal to what? 1 minute is 1 by 60 degree, right? Because 1 degree 60 minutes. So 1 minute is 1 by 60 degree. To convert degree to radian, we'll multiply directly this factor. If you want to write one step, multiply pi by 180. But let us do this calculation now. Divide by 60 further. This is going to be 0.00029 radian. Note that. Okay. See, like this it is. Okay. Then what is 1 second? 1 second is 1 by 60 of a minute. And this minute will convert into 1 by 60 into 1 by 60 further. That will become degree. And then to convert degree into this, further we will multiply this factor of pi by 180. That means further you divide it by this. Divide this further by how much? Again 160 you divide. This is going to be quite small now, 0.000048. Okay, let it keep it like this. Radian. If you want, you can keep in terms of power also. Let us bring in terms of power. Power I will bring. So I will write it here. So 1 degree can be written as 1.74 into 10 to the power minus 2 radian. 1 minute is equal to 2.9 into 10 to the power 4. I think 4. Correct? Yeah. 10 to the power minus 4 radian. Right. Correct. And 1 second will be equal to 4.8 into 10 to the power 6. 10 to the power minus 6 radian. In NCRT, they have given these values you can check. And if you can mug up these values, in some questions calculation will be easier. Now why it is? Because now I will give the reason why it is easier, why it is going to be easier. Okay, calculation. Because what is the application of small angle applications? Let us note the angle, small angle applications. Small angle, small angle application, small angle applications. Suppose you are taking a very big, you know, like distances, or this angle theta is quite small. The theta angle between two lines is quite small. So when you are taking this arc length is almost like this straight line. You may write it as smaller, but that L is very, very small. And this R is the radius of this circle. Okay. So here this angle theta, if I define this angle theta, because this is almost like 90 degree, it's like a straight line. So even sine theta, this theta can be written as sine theta also, because that's like a right triangle. So that can be taken as L by R only, right? Because this is also R. So base and hypotenuse are almost becoming like the same thing, right? Okay. So L by R. So that's what you can see, sine theta and theta can be almost approximated as well. Why? Because sine theta is for perpendicular by hypotenuse. But that perpendicular line is like a arc length L. Okay, because that line is very, very small. So we can do like this. And if you do like, remember this theta here is in radian, not in degrees. Here you can write sine theta as degree, doesn't matter, because sine 180 degree is 0, or sine phi is also 0. So whenever you take trigonometric ratios, you may write the angle as radian or degree, doesn't matter. But if you are only writing the angle, then better be careful. Okay, if I am only writing the angle, then I have to be careful because it has to be in radian. See, because when we write only angle means we are calculating the angle as arc length by radius. That time we are doing radian calculation, not degree calculation. That is where mistake can happen. Okay, right. So that's one important thing here. Okay. Now, if I consider this theta as length by radius, so I can calculate this radius as L by theta. Remember, theta is in radian. Okay, now what is the application? You may see the distance between two stars can be calculated, or distance between two planets, or the size of this. For example, suppose this is Earth. Let us say that this is Earth, and let us say this is Moon, or it may be some other planets also. This is Moon. Now, suppose from a point on Earth, if you try to measure this angle theta, this theta is first of all very small, and this diameter, although this diameter can be considered as a arc length. So this is the diameter, let us call as d, and this is the radius r here. So this angle theta can be defined as d by r. Diameter of the moon can be calculated as theta into r. Theta is in again in radian. There should not be any confusion in this. Okay. So the diameter of the moon can be calculated approximately as this angle theta in radian multiplied by the distance between Earth and Moon. These are the applications. Okay, these are the applications. Right. So, beginning from this chapter, distance measurement and units and dimension, you will see in NCERT and many other textbooks these applications are given. Then what else? Over. This is over. Let us go to the next topic. Then we should know about some formulas, trigonometric identities. Trigonometric identities. What are those trigonometric identities? First, sin squared theta plus cos squared theta is equal to 1. Second, secant squared theta minus tan squared theta is equal to 1. Third, cosecant square theta minus cot square theta is equal to 1. So from here I can also write that 1 minus cos square theta is equal to sin square theta, or 1 minus sin square theta is equal to cos square theta. Similarly here, secant square theta minus 1 can be written as tan square theta, or 1 plus tan square theta can be written as secant square theta. Similarly from here, cosecant square theta minus 1 is cot square theta, or 1 plus cot square theta is equal to cosecant square theta, like this. Like this. Same thing, right? These are from C. But there are many other things also that we'll see, but these are the most fundamental things. Okay? Then compound angle formulas, we'll see compound angle formulas. Compound angle formulas. First, sin A plus B. Sin A plus B, sin A minus B, cos A plus B, cos A minus B. Let us write first these two formulas. Sin A plus B is sin A cos B plus cos A sin B. and sine A minus B is sine A cos B minus cos A sine B. Cos A plus cos B is cos A cos B minus sine A sine B. Then cos A minus B is cos A cos B plus sine A sine B. These are four formulas. Then tan also formulas is there. Tan A plus B and tan A minus B. So tan A plus B is tan A plus tan B divided by 1 minus tan A into tan B. Similarly, tan A minus B is tan A minus tan B divided by 1 plus tan A into tan B. These trigonometric formulas for compound angles we should know. Okay, right? Yes, Sam. No problem. It's okay because I understand. Huh, okay. Okay, no problem. That's okay. That's fine. Okay. You may watch it afterwards also because we recording it. Okay, so these are six important formulas. Now, these six important formulas are very important because from this many formulas can come. So I will take examples of one and two formulas, few formulas, and I'll make some formulas from this further. Okay. So let us take this sine A plus sine B formula, sine A plus B formula. So in sine A plus B, which is sine A cos B plus cos A sine B, let us make both angles as theta theta. So let us put them A and B equal to theta theta. So that will become sine theta plus theta. It will become sine theta cos theta plus cos theta sine theta. Okay. That means what? That means this formula is going to be now very important. Sine 2 theta is 2 sine theta cos theta. This is one of the formula for the next like 2 years, grade 11, grade 12. They need to keep on using this many places. Okay. That's what it is. And if I make them here, if I take theta, suppose if I take theta here, that means it become half half, then it will become 2 sine theta by 2 cos theta by 2. Okay, whatever you want, you can write it, but this is double angle, here it's a half half angle. Okay. That's the important formula. Next we can take, this is the same formula. Next, let us take cos 2 theta formula. So same way, cos A plus B, if you see cos A plus B, this is cos A cos B minus sin A sin B. So here also if I put theta theta, so cos theta plus theta, that become cos theta minus sin theta. So that will become cos 2 theta is equal to cos square theta minus sin square theta. That formula is also going to be a nice formula. Okay, very important. Now see this formula that we are writing, it has got a major application in physics. Major application. How I will tell that? This cos 2 theta is very nice because this I can write as cos square, I will write as 1 minus sin square. Okay, and this is already sin square. So this can be written as 1 minus 2 sin square theta. Okay, same cos 2 theta can be written like this. Now, if I write 1 minus cos, sorry, this is cos 2 theta. So 1 minus cos 2 theta, I can write this as 2 sin square theta. Or I can write this as sin square theta as 1 minus cos 2 theta by 2. That has got a major application. Why major application? Because here note that the power is degree is 2 here, degree is 2, and here 2 is multiplied, degree is 1 only here. You got cos 2 theta it is. So the power of trigonometric ratios power 2 can be converted into power 1 using this formula. Okay. Same manner, if I write, that means sin square theta can be written as 1 minus cos 2 theta by 2. Right, that's the important idea. Or you may also write this as sin square of theta by 2 can be written as 1 minus cos theta by 2. That also can be written. Okay, but let us now try to bring this in terms of cos. Now let us write sin square as 1 minus cos square. So I will use again this one cos 2 theta as cos square theta. Sin square I will write as 1 minus cos square. So now what will happen is this will become as 2 cos square theta minus 1. Hmm? So from here 1 plus cos 2 theta. This can be written as 2 cos square theta. So that's what I put result. Now here from here I can say that this cos square theta can be written as 1 plus cos 2 theta divided by 2. Cos square theta can be represented in terms of that, and so cos square theta by 2 can also be written as 1 plus cos theta by 2. All these are major applications in physics, major applications. So if you know clearly these basic trigonometric formulas, calculations and transformations of one ratio to another things, these things will become very easy, right? This has got lot of applications. Mm, right. Okay, so we will see lot of its applications out there. And then compound angle formulas. Over. What is the next? Next, we have to see about sin C plus D formulas. Yes. So sin C plus sin D. These formulas has got major applications in oscillation and waves. Sin C plus sin D. Sin C minus sin D. Let us first do these two formulas. Sin C plus sin D is equal to 2 sin C plus D by 2 into cos C minus D by 2. Okay. Note that when you are doing this, 2 sin cos is multiple, but sin has got more angle and cos has got less angle. That is what you have to know. Similarly, sin C minus sin D is 2 sin C minus D by 2 cos C plus D by 2. Here cos gets more angle, sin gets less angle. That is what you have to remember. Okay? That's what you need to remember. So, so sin C plus sin D is 2 sin C plus D by 2 cos C minus D by 2. Sin C minus sin D is 2 sin C minus D by 2 cos C plus D by 2. Okay, that's what it is. Then what? Then here the reverse or corollary we have to know. Corollary. Corollary I will tell. Okay, what is corollary? Corollary is, suppose if I have sine A into sine A into cos B, I have sine A into cos B. Corollary means reverse of this. I am going to take this as C plus D as A and C minus D as B. Okay. Note that A is larger here. So I will write this as sine of C we will get by adding of these two. So we will do A plus B adding of this. Okay, and divide by 2, of course we have to divide. And plus sine D you will get by subtracting this. subtracting this, which is a minus b. This is what we need to note. So sin a cos b can be written in this way. Hmm? Here we are taking a greater than b. Okay? A greater than b, this will do like that. Similarly here, if I consider sine, let us take a as smaller now, c minus b, okay? And this is cos b. Here I am taking a as smaller. Let me check if any changes happen here or not. Then I will write sine first c. C means what? C means I have to subtract this minus this, bigger minus smaller. No, I need to add them. Sorry, I need to add them. So if I add them, it means b plus a or a plus b. I think it is not going to affect the formula. Might be formula in a same order. No, minus sign is coming up. And d I'll get by subtracting this minus this. That means b minus a. Sine b minus a I need to do. Okay, divided by 3. Correct. It looks correct now. Check this. Hmm, looks correct. Okay. Then these two formulas are over. Corollary. Corollary will be used because in wave equations we will be using this. Okay. Then cos c plus cos d, cos c plus cos d, and cos c minus cos d, cos c minus cos d. Okay. So what is cos c plus? So when cos c plus cos d comes, 2 cos comes. Okay, remember that. Here c plus d by 2 and c minus d by 2. And here 2 sin comes, sin c plus d by 2. And here sin d minus c by 2. This is what we need to remember here. This is a small change happens here. Okay, so now if I have to write corollary, for example, cos A into cos B can be written as if I add them. Hmm? So cos A plus B plus cos, if I subtract them, A minus B whole divided by 2. This is what we can. Similarly here corollary, let us write corollary. So sin A into sin B. Sin A into sin B can be written as cos C I want. C I want means I need to do this minus this. Here I am taking A is bigger than B. Okay, this is bigger. So I will do cos this uh, plus if I do I'll get B. Okay, I need to subtract them. So I will do subtraction A minus B. Okay, then minus cos. Now I want D. I will add them. So this is A plus B. Okay, and this divided by 2. So these formulas have got major applications in oscillation and waves because all the sinusoidal functions comes there and all these calculations we have to do this, right? Correct. So let's quickly finish this. It will be quickly we'll finish that 5 minutes more. Just finish this. Trigonometry at least we'll finish today. Okay, so that next coordinate geometry one class I'll finish this. Okay. Then next is what else is remaining in trigonometry applications. These are the things. What else? ASTC rule, which is always confusing. ASTC rule, but ASTC is a waste term. That is not needed. But let us see that. Okay. quadrant. This is quadrant. So here the angle in this quadrant, any angle you take, angle will lie always between 0 and 90 degrees. Here second quadrant, angle will lie between 90 and 180 degrees. And here the angle will lie between 180 and 270 degrees. And the fourth quadrant angle will lie between 270 and 360 degrees. Okay. So first of all, note that here all trigonometric ratios are going to be positive. All is positive. Here sine is positive. All sine. Sine is positive means automatically its reciprocal cosecant is also going to be positive. All sine. Here tan is going to be positive. So definitely cot is also going to be positive. Here all sine tan cos is going to be positive. So secant is also going to be positive. Okay. So how do we use interconversion? For example, suppose if I want sine of, let's try to understand this, 90 into n plus theta. Okay. How to convert that? So first of all, the signs plus minus that we write here, it will, let me call it as sine, S-I-G-N, sine. This sign will depend on which quadrant it is. Quadrant. For example, let's take example. Suppose n is 1 here and theta is 30 degrees. This theta is always we try to write as acute. This theta is a acute angle. Okay. This theta is a acute angle. Okay, so this theta is a acute angle here and n can be anything. So this sign will be based on quadrant. Okay. Yes, Kshatrish, welcome. So here little bit we are winding up this class of grade 11. So few minutes we'll wind up this trigonometry. Then we will start. Yes, so this sign will depend on which quadrant it is. Okay, and this theta has to be acute, right? And this sign will convert into cos or will not convert into cos. It will depend, okay, whether it will convert or whether it will not convert. Okay, so this sign plus minus, that of course we have to write based on which quadrant it is. Okay, but this cos theta or sin theta, it depends whether n is odd or even. So cos theta conversion will happen if n is odd, right? And it will not convert if n is even. Okay, right. Let's take example. For example, take sine of 150 degree. Sine 150 degree can be written as sine 90 degree plus 60 degree, right? So here we can say that it is like 19 to 1, 19 to 1 plus 60 it is. So first of all, 150 degree is coming in the second quadrant. Second quadrant sign is positive. So first of all, we will give this value sign here plus it is going to be, and it is odd, right? 19 to 1 odd. So this sign is going to convert into cos 60. That means its value is going to be half. Okay, that's how we calculate. And so conversion that happens, you should know that sine can be converted into cos or cos can be converted into sine, both vice versa. Similarly, tan can be converted into cot and cot can be converted into tan. And similarly, secant can be converted into cosecant and cosecant can be converted into secant. So this is how it works. ASTC rule, it is called ASTC rule. ASTC rule. So A means all, S means sine, T means tan, C means cos. So the first quadrant all is positive, second quadrant sine is positive, third quadrant tan is positive, fourth quadrant cos is positive. But see, I don't have to do this because this is just a waste of time. I think this ASTC is a completely waste nonsense because what happened is that any angle you give, I can calculate without using this rule. There is a simple method of coordinate geometry. Okay, coordinate geometry is simple method because this sine plus minus and all that blah blah comes because of that quadrant only. Quadrant. So let me take this angle, na? 150 degree I want. Okay. See, let me tell you this. Suppose I want to find out what is sine of 150 degree. I don't need that rule. Okay, it's a waste because if I draw a quadrant, sine 150 degree comes like this way somewhere, right? This is 150 degree. So if I want to calculate this, I will simply take it like this. You draw this triangle, and this angle I will calculate. I will calculate in this triangle. This is 150 degrees, so this is definitely how much? 30 degrees. 30. So sine 150 degree, I will calculate sine 30 degree from, because this triangle only I want to use a right triangle, right? This triangle I will use. But when I am using this triangle, note that this side, this is going to be negative, this is going to be positive. Okay, and hypotenuse is always positive, note that. Because this quadrant, in second quadrant, x coordinate is negative, y coordinate is positive. Hypotenuse is always positive. So when you use sine 30 degree, sine 30 degree when you use perpendicular by hypotenuse, that means in this triangle that is same as sine 30 degree, which is going to give us half. What is the need of that? No need, right? No need. Suppose, suppose if I want, suppose if I want sine of, let us say, 330 degree. I want sine 330 degree. So what I will do is I will construct this, right? And note that angles are always measured anti-clockwise. So I will say that this I am measuring, this I am taking as 330 degree. Okay. So if I take 330 degree, that means this must be 30 degree because total is 360 degree. Now I will make the triangle like this way. I will make triangle like this way. So instead of calculating for 330 degree, I'll calculate for 30 degree in this triangle. And note that here this is going to be positive and this is going to be negative. Hypotenuse is always positive. So I have to write the value of sine 30, but note that perpendicular is negative. So I have to write minus, and sine 30 degrees half. That's how I have to do. I don't need this, base rule. That is a base rule because we have to tell students remember this and all that. What is the need? Coordinate geometry, you draw and draw this triangle and calculate. That's it. That is better, na? No need for that. Okay. So that's how we use this trigonometry tools. Okay. Anything is there, we can do it like this also. And some basic thing like people will remember, like sine 90 minus theta is cos theta, cos 90 minus theta is sine theta, right? All this rules that comes, all this comes. Sine, similarly sine 90 plus theta, sine 90 plus theta, cos theta. Like all these rules are there, na? These are coming from the same thing. From yes, this rule it is coming, or it is coming from this quadrant. Okay, that's nothing new. You can do that, right? Okay, so done. I think now we are done it. Done. Okay, and here there are some applications in physics that is very important. I will tell about the sine rule and the cosine rule, which are very useful. Particularly, you will have exam for kinematics and forces also it will be coming. So very important rule is sine rule, which is also defined as Lami's theorem in physics. Lami's theorem. Lami's theorem. So what is sine rule? So suppose there is a triangle, okay, and let us say this is ABC. This angle is capital A, capital B, capital C. Opposite of this is side A, opposite of side this, opposite of side this. So what happens in that? The ratio A by sine of capital A, B by sine of capital B is C by sine of capital C. This ratio is equal. This is what is called sine rule. Okay. Note that in Lami's theorem, you say that there are three forces F1, F2, F3 are acting at a point, that means they are concurrent, and the sum of all the forces vector sum is 0, right? Vector sum of all the forces is 0, we say. So we apply this Lami's rule because opposite of F1 is alpha, opposite beta, this is gamma. So we say that F1 by sine alpha, F2 by sine beta, and F3 by sine gamma. This is what it is. Okay, these ratio is equal. Now you will say how this is related. It is related because suppose I want to make a triangle using this F1, F2, F3, because this is the sum of three. 0 means they will definitely make a triangle. Let me make a triangle. So this side represent F1 in this direction. Okay, F2. F2 is like this. I will take this F2 like this way. Okay, this is F2 I take. Then F3 I have taken in this. So see, the sum of all the three factors is going to be 0. Okay, this I will write it. So sum of F1 vector, F2 vector, F3 vector will be 0 because they are in the same order. They will cancel out, right? Now tell me the sides, angles of this. So if this is F1 and this is F2, note that this is the direction of F1, right? And this is direction of F2. This is direction of F1, this direction of F2. So angle between F1 and F2, that is what is how much? That is what is gamma. So this will become 180 minus gamma, right? Similarly, if you see the angle between F2 and F3, that is alpha. This is F2, F2, this and this is F3, right? This angle is alpha. So this becomes 180 minus alpha. Similarly, this F3 and F1, this is the direction of F3, right? F3 direction. So F3 and F1, that is beta. This angle is beta. So that becomes 180 minus beta. Now, in this triangle, you can apply this rule, sine rule. So if I say F1, opposite of F1, you see sine 180 minus alpha is there. So that will become sine 180 minus alpha, right, is equal to opposite of F2. Opposite of F2 become 180 minus beta, so that will become sine 180 minus beta, right? Similarly, equal to F3, opposite of F3, sine of 180 minus gamma. And you know that sine of 180 minus theta is same as sine theta. So that's how it is coming from here. F1 by sine 180 minus alpha becomes sine alpha. Similarly, F2 by tan 180 minus beta becomes sin beta. Similarly, F3 by sin 180 minus gamma becomes sin gamma. Here, right? That's how it is coming. So, the sine rule or Lami's theorem, they are nothing but the same thing. Okay? And we use them in equilibrium. Whenever forces are equilibrium, we use this. These days, no, the grade 11 students are working a lot in this type of problems. Okay? You know, the forces it comes about. Right? Okay, then what is cos rule and cosine rule? Cosine rules. Cosine rules. So in a triangle, suppose this is angle ABC, opposite is this ABC. Suppose I want cos A. I want to write cos A. So cos A becomes B square plus C square minus A square by 2BC. Similarly, if I want cos B means adjacent square, right? A square plus cos b I want. No, so cos b I want means a square plus c square minus b square by 2ac. Similarly, cos c I want. Cos of this angle c means a square plus b square minus c square by 2. So this can help us to quickly find the cos of. If you know the sides, if you know the sides, you can calculate cos. Right? Okay, so let us wind up this chapter. This topic is over, and okay, this time will take 2 minutes break. Okay, then we will start the next. remain here in this. And also, I need to send this. So let me come up with